Looking up at the top, just that basic example, 15 over 8 times 2 over 35. If I'm just multiplying two fractions, how do I do that? Do what? Not cross multiply. If it was cross multiply, then I got that same answer first period. If it was something like this and you're having to solve for x, you would cross multiply and solve. But if I'm just saying this fraction times this fraction, how do I do that? Just multiply straight across. Okay, 15 times 2 is 30. 8 times 35 is 280. All right. And then if you could you can simplify it to 3 over 28, that's as far as that one will go. Okay. So whenever you're just multiplying two fractions, all you're going to do is just multiply straight across. Okay. All right, so getting into this example, again the notes are pretty short today. We're only doing two problems, one multiplication problem, one division problem, because I do think it's pretty straightforward. So the very first step is you're going to factor. In parentheses up there you might put if you can. Now the examples on the notes you can, and those are probably more complex than the first few examples you're going to see on the homework, but some people in first period started freaking out because they were trying to factor something that you can't actually factor. Okay, so if you can't factor it, you just leave it alone. But if you can factor it, then you need to. So let's look at these. So the numerator of that first one, since there is no leading coefficient, what factors of negative 2 add up to negative 1? Factors of negative 2. Do what? Negative 2 and positive 1. Right. Let's quickly review how we factor these whenever there is a leading coefficient. So I'm just doing the denominator of that first fraction. Before we get too far into that, whenever you factor these, don't move them to another part of the fraction. I've had some people kind of get confused on that, which I don't know. So whenever you factor the numerator, it's still going to be your numerator. It's just now it's factored. Same with the denominator. Your denominator would just go down there. All right, so that's how you place it in there. So let's go back up here and factor this. 2 times negative 2 is negative 4. And so what factors of negative 4 add up to negative 3? Negative 4 and positive 1. Whenever I have that leading coefficient, what do I have to do with it now? Try to divide by it. Does 2 divide evenly into 4? Yes. So I have x minus 2. Does 2 divide evenly into 1? No. So where does it go? In front of the x. Having to factor these down, this is the hardest part of these problems, which hopefully isn't that hard because we've been doing it pretty much all year. It's just you've had the last 2 weeks to sit around and sleep until 1 p.m. Okay. Looking at the second fraction, the denominator, that one should be pretty easy to factor Because the first thing I always need to look for, and we didn't look for it in the first two because they didn't have one, but you always need to look for the greatest common factor. What would the greatest common factor be for those two? What can I pull off of both of those terms? Just x. Okay. Whenever I pull that x out, I'm left with x plus 1. Okay. I want you to factor the numerator of that second fraction. It is the exact same process as what we did on the denominator of the first problem. On this one, you should have gotten x minus 3 times 2x plus 1. Now go ahead, just because I don't want you to cross through that, I want you to kind of see the steps on the notes. I want you to rewrite all of those down below on step 2 for me. So just right there. Go ahead and rewrite those real quick. I'll do my best to kind of draw a connection between multiplication and division to addition and subtraction, even though we haven't talked about it, but since I won't be there, you might be able to draw these comparisons once you've set through both lessons. This is one of the things that makes multiplication easier than addition and subtraction. It's because now we're going to go through here and we're going to cancel out as many factors as we can. Okay? In addition and subtraction, you can only cancel out factors within each fraction. Alright, so you'd have to just ignore this one and see if you could cancel something out. And then you'd come over here and see if you can cancel something out here. Whereas in multiplication division, you can cancel something from here with something over there. Alright, so you can cancel out two things that are in the two different fractions. So looking at that, what are two factors, or what's one factor that will cancel? 2x plus 1. Okay, Sadarth, what's another one? X plus 1. And Jen, what would the last one be?
X minus 2.
X minus 2. Okay. So, whenever you write your answer, you would just go through the numerator, both numerators, and whatever is left, that's going to be the numerator of your answer. So on this one we're left with x minus 3. Whatever is left in the denominator, that is going to be the denominator of your answer. Alright, so you would have x minus 3 over x. Now, one thing that you need to make sure that you know how to find is something that is called the excluded values. Okay? And these are values that x cannot equal because, like I said, we're talking about fractions, which means division. And what is the one number that you cannot divide by? 0. Okay? So on this one, there's quite a few values that x cannot equal, and this is where I kind of get in trouble because a lot of times I will just find the excluded value of the answer. You need to find the excluded value of the actual problem. Okay, so kind of look up here with me in step 1. You just want to think, if I set these factors equal to 0, what would they give me? So, what would x minus 2 give me? X equals 2. What would 2x plus 1 give me? If I set that equal to 0. Ms. Kaufman, what would that be? Negative 1/2. Don't forget these factors that are by themselves. Okay, if it's one of those it's just out in front of a set of parentheses, that's always going to give you 0. Even if it said 2x or negative 4x or 7x. Those are always going to give you 0. And then that last one's going to give you -1. Okay. So how you would write that with your answer, because you're saying that x cannot equal those numbers, you're just going to put that, and then you'll list the numbers. The order does not have to be, order doesn't matter, it doesn't have to be in ascending order or anything. Okay. You could have 4 excluded values, you could have 1 excluded value. You have 2, 3, just however many factors there end up being on this bottom across the numerator, that's how many excluded values you're going to have. Okay. Some confusion also, or it wasn't confusion, but I talked about with first period. You're not always going to have just one, what am I trying to say? You can have multiple factors in your answer. Okay, and what I mean by that is, your answer could look more complex than this. Okay, it could be something like that. So don't think it's always just going to be one on top of one or something. All right. So that is multiplication. Any questions on that? Hopefully it's pretty straightforward. Factor where you can. Cancel out. What you have left is your answer. Identify the excluded values. Alright, which is weird because it's multiplication and nowhere in there did we ever even multiply. But so let's look at division. Turn over to the back. So just looking at the example that we have up here with just numbers, how do I divide 2 fractions? It's embarrassing, Trent. Why would you say that? How do I, if I have a fraction divided by another fraction? How do I do that? Okay, I'm going to multiply, but what do I have to do before I multiply? What else do I do? What do I do with that second fraction? Ms. Romano? Flip it. So you will multiply the first fraction by the second fraction's reciprocal. And the reason why I said multiplication and division are pretty easy is even whenever we get down to the polynomials, everything's the same from this point on as multiplication. You do the one thing at the beginning if it's division, and then it's the exact same process. Okay? So on this one you would have 75 over 30. Okay, and then you could reduce that down if you wanted to. So that would be 15 over 6. Probably go even further than that. Five over 2. Okay. So whenever you're dividing, you will multiply by the second fraction's reciprocal. Alright, so let's go down here. So again, steps 2 through 6 are the exact same as steps 1 through 5 on the front of the notes. Okay, it's just at the very beginning, your first fraction is going to stay the same. And I'll zoom in so that's a little bit bigger for people in the back. And then the second fraction you will flip. Nope. Okay. Somebody tell me why those four are going to be easier to factor than some of the ones that we had on the front. They don't have the leading coefficient, the coefficient in front of x squared. Okay? So, this isn't really set up correct. I forgot to format that. There's not enough space in there to write what we need to write. So, factoring the numerator of the first fraction, what factors of negative 6 add up to negative 1? What factors of negative 6 add up to negative 1? Yes, negative 3 and what? Negative 3 and positive 2. If it helps you, if you're finding the factors of a negative number, that means the signs are going to be what? Am I going to have two of the same signs, or am I going to have one of each? One of each. So on this one, if I'm finding the factors of negative 4, I know I'm going to have one positive and one negative. Okay? If you can notice that, if you're struggling with the factoring, if that helps you, write that in and then figure out what numbers make sense right there. So, what factors of negative 4 add up to positive 3? What are some factors of negative 4? 4 and negative 1. Alright, so on those you should have gotten x plus 4, x minus 2. The denominator is one that some people struggle with. You should have gotten x minus 3 and x minus 2. You got to be careful because, again, if you're finding factors of a negative number, like right here we had negative 6, negative 4, and negative 8, the two signs in your factors are opposite. That last one we were finding factors of a positive number, so your two signs are always going to be the same. Okay? And if that's positive and that's negative, then they'll both be negative. If that's positive and that's positive, then they'll both be positive. Okay? It's just kind of a way to maybe figure out what the signs are, then you'll just have to figure out what the numbers would need to be. So again, looking at this, we're going to do the same thing. We're just going to go through it and find stuff that we can cancel. But actually, before we do that, it's usually this step before I cancel stuff out. This is where I'll find my excluded values, not at the very end, because I have everything I need to find those. All right, so I'll have to write my answer off here to the side. But Brianna, what would one of my excluded values be on this problem? Okay. Catherine, what would another one be? would another excluded value be from there? So take any of the factors in the denominator and set it equal to 0. So like if this one gave us 1, so this one would give us what? X equals -4. Okay, Tanner. And Trent? 2. Okay. So there's my excluded values for this problem. So now I can go ahead and start canceling stuff out. So, Bree, what is a factor that I can cancel out on this one?
2.
X minus 2?
Yeah.
Lisa Better, what's another one?
X plus 4.
Okay. Rhett, what's the last one?
X minus 3.
Right, so all I have left in the top is x plus 2. All I have left in the bottom is x minus 1. You can write this down at the bottom, I just don't have space down there. So all of this would be considered your answer.